Dear participants and students, I am Dr. Chandranath from JIS IASR, and today my webinar topic is deep learning and its application, and it is a recurring webinar for next 2 days as well. Before going to directly to my topic, it's a small promotion of our institute, that our institute is a postgraduate academic institute, and we offer multiple courses like MTech in computer science and engineering with specialization in data science and specialization in machine learning, MTech in sensor technology and IoT, MTech in bioinformatics, MSc in polymer science and technology with specialization in paint and coating, and MSc in medical biotechnology and bioinformatics. So for admission, you can email to this email ID like admission@jisisr.org and info@jisisr.org. And here are some phone numbers are available as well. So in these recurring webinars, today I will cover mostly neural network and introduce you the what is deep, and some hands-on application on optimizing a function. Next day, tomorrow, we will cover convolution neural network and some hands-on application on computer vision. And the third day, recurrent neural network and also hands-on application on natural language processing. So here we can't cover all the things. We will just glimpse you what we are doing and what is in our courses like MTech in computer science with specialization in machine learning and as well as in data science. So requirement to attend this webinar, I will pause here to request you to grab some pen and paper quickly and a computer with minimal configuration. We just need the internet connection and one Google account because we will process all our work on Google. And the foremost requirement is your kind attention. So we will pause here for say 30 seconds or say 20 seconds to request you to grab some pen and paper. Kaushika, it is audible properly? Hello. So the next thing, machine learning or how it's related with deep learning, or actually what is learning or what is this deep thing. So here I have drawn and drawn a diagram that is here. It is overall thing is AI or artificial intelligence. Under this subset is machine learning, and under this it is deep learning, the subset of machine learning. So in this webinar series or 3 days webinar, we will mostly cover the deep learning, and you also heard or learn some topic of the machine learning through our past webinars, and you will learn more on in future webinars as well, like next day's webinars as well, the machine learning. So, and here just a brief overview of that, say 20 deep learning applications like self-driving car, entertainment, like fraud detection, NLP or natural language processing things, colorization, black and white images, some healthcare things, and some automating game playing, pixel restoration, etc. These are the more specifically of the 20 top applications. So we will start today from the basics of neural network, and we will cover like what is actually the learning is, and then we will do some program or hands-on that we have to learn some parameter or what is this actually. So Professor Rohan Mukherjee actually covered few topics about the regression analysis. He gave overviews of the what the regression is. Regression and he also told about the classification as well. So here the thing is, for say you want to know some, for example, you want to know some car price. So car price may depend on some say some mileage or some car's wheel or say color of the car, etc. So here if I say it is say x1, x2, x3 or car price say y. So car price will depend on this x1, x2, x3. It is nothing but a function of x1, x2, x3. So say mileage say 15, will say 4, color say black. So here are some car price, some say something say 3 lakh. So here we have some say x1, x2, x3 are given. We want to predict what is the car price is. So we have to learn some weight values. I will come to this weight values, what is this and that. And another example, it is simple regression problem, and another example is classification. So you want to classify say, you want to say classify say for this time, say it is apple, and say I am giving some very like initial example. Okay? Say this is a banana. Okay. So here some features are, say for example, some features are say x1 is say shape, say x2 is color, y is we have to know whether it is the fruit or the image is, or the image of the fruit is banana or say apple. So here say shape say round. Say round means say 1, or say it is some this like the banana like shape, it is say 0. Or color say it is apple means say red, or color maybe some value RGB values, or it is say yellow. So if I put say 1 means say apple, or banana means 0. So here we want to classify this y, we want to classify based on this feature values x1 and x2. Here also y is some function of x1, x2. So another example, another example, say you have truth table, right? Or table or truth table. So you have x1, x2, say y. So here if I write 0, 1, 0, 1, if we have odd, it will be say 0, 1, 1, 1. Okay, so it is nothing but y is nothing but a function of x1 and x2. So if I give you 2 zeros, you will definitely tell that what is the output or what is y here. So it is function of x1 and x2. Say, and here we want to learn systematically, or learn through program, or learn through the architecture is called say neural network. Nothing to do with name, it is say something which nothing but a function. So it is a function of those inputs. Say in input layers we have x1 and x2, and suppose this function, or say here it is say z, and we are giving two weight values, say w1 and w2. So these w1 and w2 are the parameters. More specifically, it is the learning parameters that we have to learn. In the learning techniques, or in deep learning techniques, the learning is you have to learn these weight values. So here the z means a simple equation. Z is nothing but x1 w1 plus x2 w. Here after combining this, we'll use some activation function. I am just giving the terminology because in details we can't cover in this short period of time. In our course, we will cover this all of these things. Or if you are interested, you can email me at chandra@JISIASR.org. You can email. Sorry. You can email me here as well if you are interested. We have to add some activation function. And after activation function, say activation function sigma. After activation function, we are predicting some output. Predicting some outputs means here it is a y hat here I am writing here y hat equal to one activation function. It is called sigmoid activation function. Sigmoid of z. It is nothing but one small formula 1 plus 1 by 1 plus e to the power minus c. Here after this, what we have predicted, this y hat is the predicted value. So predicted. Y hat is the predicted, and this y is the actual value. I will give some examples so it will be more understandable. So after that, here we'll calculate some loss. Loss equal to nothing but some differentiation, y actual minus the predicted. There are multiple types of loss functions are as well, loss function. So here what we will take, half squared error. We are calling is half squared error. It is our loss function. So now for example, say here it is 0, x1 is 0, x2 is 0, x1 is 0, x2 is 0, one sample. It is say sample 1, 0, 0, sample 2, or data point you can say sample 4. We are taking sample 1, it is 0, 0, so 0, 0. W1, W2, at the very first stage, we will take it as a random value. Say random value, say we are taking W1 equal to say 0.4. W2 is say 0.2. Okay. So now calculate z equal to x1 into W1 plus x2 into W2. What will come? It will be obviously it will be 0. So after that y hat, say now calculate z equal to 0. So if we calculate here, put z equal to 0, what will be here? 1 by 1 plus 1, it will be 2 equal to 0.5. So here y hat will be 0.5. The actual value is 0. You are expecting this 0, the actual value, but you are getting 0.5. So there is loss, some error is there. It is, we call some, there are various names. It is sometimes you call it as loss function or some error function, anything like that. So now calculate the loss. It will be half of y is the actual value was 0. You are getting y hat means 0.5. Means how much you are getting. You just calculate this. You will get 0.125. So 0.5 square 0.25 divided by 2, it will be 0.125. So loss is 0.125. The actual, or sorry, not actual, the target loss is 0. It will be similar. The expected and actual will be similar. So our target loss is 0. So for that reason, we have to calculate the change. So what we have learned initial phase, at the initial phase W1 and W2, we have not learned anything. We have just randomized this 0.4, 0.2. So we have to learn for what value of W1 and W2 the loss will be minimum. Minimum means 0. Or here we can plot this loss function as well. The loss curve will be like this way. So L, or it will be same, it is weight value say parameter something. Why it is coming this parabola shapes? Because we all know the parabola equation equal to y equal to 4a squared. This formula is for parabola. So here it is also square. So you are getting some parabola like shape, the loss function. Okay. So I'm not going into detail for all of these things. Okay. So now what we have to do? We have to learn this W1 and W2. So for that reason, what we will do? We will tell our architecture, see this loss is this much, so you have to recalculate this thing. So we will back propagate, this is a special term, back propagate the loss to here or to again calculate the W and W, but it can't jump this way. It will be like one by one, this layer, this one. Okay, one by one. So there we have to change. We have to change the weight parameter. We all know the rate of change is some differentiation. So those having knowledge of the calculus, you know there is a term partial derivative. We write like this, like del x by del y, partial derivative. Rate of change of this predicted value. We have to change this predicted value to 0. So that reason we have to calculate some basic calculus is there. Like for example, we have to calculate. We have to calculate del L, like this loss, del L by del W1. Like we have to rate of change of this parameter. We have to learn this. And besides, we have to calculate del L by del W. I am calculating this one at first, then you can calculate this as well. Hope you all have brought your pen and paper, so you can calculate. Okay. So del L del W1 is nothing but there is a chain connection we can use, del L by del y hat into del y hat by del z, because L is dependent on y hat is dependent on z, and z is a function of this W1. L is a function of y hat is a function of z, and z is a function of W1. So similarly, del z by del W1. See, this thing can cross out, so it will be del L by del W1, simple. Now we have to calculate this differentiation. So del L by del y hat, how we will calculate, differentiate this equation? So what it will? Del L by del y hat, you have to calculate del y hat. L means what? This one, half of y minus y hat square. We have taken these two terms, so it can be cancelled out. So it will be 2 into y minus y hat divided by 2, that will be cancelled out. And for this y hat, there will be some minus symbol. Okay. So it will be minus of y minus y hat. So what is y value now? Oh, I think this. Sorry for my color choice. So sorry. Y means 0 and y hat we have calculated, it is 0.5. So it will be 0.5. So del L by del W1, this portion has calculated, del L by del S, it will be 0.5, or say into Now we have to calculate del y hat by del z. I am deleting this portion, okay. So I can get some space actually. So del z of y hat, this portion. Y hat means y hat is written here 1 by 1 plus e to the power minus z. So it will be 1 by 1 plus e to the power minus z. If we calculate, I think you all know the basic calculus. So when you will calculate, you will get e to the power minus z by 1 plus e to the power minus z square. Because e to the power minus 1, so minus 1 equal to minus 2, and that will come out here minus, and for this minus it will be plus. So this equal to, so if we calculate these things, 1 by 1 plus e to the power z into e to the power z by 1 plus e to the power z. Simple. Like I am just calculating in different way, dividing in different way. So I am giving 1 plus here, 1 minus here. See, this portion 1 by 1 plus e to the power z, it is nothing but y hat. See this thing. So I can write this y hat into, this will be 1 by 1 plus e to the power z plus 1. So 1 plus, sorry, this one, 1 plus e to the power z by this one. So 1 minus, this minus, 1 by 1 plus e to the power z. So it will be 1 minus 1 by 1. You can calculate this. So we know the y hat value. This is the y hat value here 0.5. So 0.5 into 1 minus 0.5 equal to how much? It will be 0.25 obviously. So 0.2. Now calculate del z by del y. It is the very basic. So again I am deleting this portion. So del z by del w1, it is nothing but del by del w1, z equal to what? w1 x1 plus w2 x2. So this will be obviously, this term will be 0. Okay. The only term will be x1. Okay. x1 means what? x1 means 0. So it will be 0. I gave you the task for del z by del w2. It will also be 0. So that term del l by del w2, it will also be 0. So it will be 0. So our all tasks in vain. Like we can't update the weights because it comes 0. So there is a, I omit one term intentionally. There is a most crucial term is one bias. One bias should be added here. So this equation z equal to x1 w1 plus x2 w2 plus this bias term should be added, because if somehow this x1 x2 or sorry w1 w2, these learning parameters are cancelled out, then bias will save us. So here learning parameters are w1 w2 and b. So similar way, so here if we, so we have to calculate, so del L by del W2 also comes 0, and if I calculate del L by del B, that bias term, obviously it will come say del L by del Z into del Z by del B obviously. So we have already calculated del L by del Z. Del L by del Z is 0.5 into 0.25 equal to, this will be 0.125, and del Z by del B, it will be obviously 1, because del Z by del W1, it Z, now Z is W1 x1 plus W2 x2 plus, so if we calculate this, this will be 1, so 0.125. So there is a equation there is a equation gradient descent. We call this as gradient descent. Using that, this task actually is by gradient descent. We sorry, because we have decreasing the gradient gradually, and our target is to minimize this cost function. So target is minimizing the cost function. How we are doing? Gradually decreasing the gradient. Here one formula is simple formula is there. W or weight learning parameters is equal to, we are assigning W minus alpha into say del L by del Wi. So it may be W1. When it is W1, it will be this. So it is 0. So nothing can be changed. So for bias also, B equal to B minus alpha into del L by del beta. So see, it will be, previously I forgot to mention, previously the bias was also 0 initially, and initially the bias was 0, and say for this time being, say learning these things, alpha equal to say 1. So del L by del B, it will be minus 125. So what we have to do, we have to decrease this learning parameter by 0.125. Okay, so we have to decrease this thing so that we can adjust. So, and I have calculated only for one iteration. We have to learn this multiple times. In neural network term or the deep learning time, we call this as epoch. And one small thing. So I am writing these things in a brief way again. Okay. I'm deleting this. Hope you understood. So our target is learning parameters. Parameters is in our previous example for or get example, it was W1, W2 and B. Our target is minimize the loss. Okay. For one sample, we are calling it as loss. For overall all the samples, we are calling it as a cost. Cost is nothing but sum over loss. If we get time, we will elaborate this as well. Target. How we will do this? In the previous example, we use the gradient descent method. So I have drawn one like parabola like structure. It is a loss, or you can say it says J. Cost is actually J. J equal to sum over L. So I equal to say 1 to nth sum. Here it is the learning parameter. So initially randomly we have chosen some say Wi, some parameter. So for this the loss is too much. So we have to decrease this to come over here. We have to decrease this. Again, we can choose here as well. So again, we have to like do these things. Our target is to minimize this loss function. So we'll do this in program. So I think that will be easier for you to understand in this short webinar time. Up to this clear, or anyone having any question? Okay, we'll jump to the program. So for this, we'll take help from Google Colab. It is a for specific tasks, it is free, But if we want to do more elaborated tasks, then we have to give, they will charge, the Google will charge, I think $10, yeah, $10 per month, US dollar. So write Google Colab. For this reason, you need the Google Drive or the Google account. So those do not have this Google or Gmail account, kindly open one and type here Google Colab. Okay. So using Google Colab, click here. So the good thing is that you don't have to install anything, or you don't have to waste enough time for installing these things. For small project. Okay. So here, click here new notebook. So you can change here which account you want to do. I am choosing this account. So here again, sorry, again new notebook. You can give some name here. I am giving say name webinar 1. So for this reason, we we are very much thankful to the deep learning frameworks or the deep learning tools. For this reason, we don't have to calculate those things, those back propagation, those gradient descent. All we can get some functions, but there is a but or big issue. For research purpose, or if you want to change internal things, we have to know the nitty-gritty of those functions. But for this short span of time, I can't like I can't I am not able to do that like in internal part. So those things will teach in our courses, like regular courses. So here import NumPy. NumPy is a famous library. Those terminologies are like new to you. The best thing is self-learning. You just type here NumPy, you will get all these things. Okay, the self-learning things. Or otherwise, you can email me as well. NumPy as NP. We have imported these things. And here for this initial task or the today's work, I will import the TensorFlow version 1. So for this, TensorFlow is a framework, NumPy is a library. TensorFlow but version 1, I will call version 1 as TF. And I will disable the latest version. Disable. Because today's task is very much like very basic task. Disable version 2 behavior. Okay. So you can, after writing this, you can press Shift Enter, or here, yeah. You can run all these things. I prefer this is also you can do run here. Okay. So there will be some warning because we are disabling the feature of these things. Okay. So one more thing, what we actually want to do in the programming tasks is, at first we want to, we have say for example we have a equation say w square plus sorry yeah, w square plus say 25 minus say 10. Okay, so it is nothing but the square root will be w equal to 5 obviously. So here w is our parameters we have to learn. So our system will give us w equal to 5 or some nearest value, say something 44998 or 4.78 like that. So let's check what it is. So it is our task. So for this reason, we will define some cost as first. So cost equal to W square. This is simple notation like W square like this. Intensity minus 10W plus 25. And what is W here? That we have to define. So W we have to define. W is some variable. Okay. So TensorFlow variable we can define as TensorFlow dot variable. I think is capital. You can wait here. Automatically some option will come. Variable. Then initial value is 0 and data type is dot float 32. I am taking 32. So the training portion is tf dot train, and we are using gradient descent optimizer. That is done. We don't have to like. Currently, we are not using or changing internal anything. Gradient descent optimizer. Here we are putting the learning rate. What I have told the alpha in the example or in that work, I choose it's 1. Now I am choosing it's say 0.01. And our target is to minimize this cost. What in the program in the theory portion I have defined this as a loss. You can write it in cost or loss. And then some syntax for initializing the global variables initializer. We have to start one session as well. Session equal to tf dot. Now this is capital S session because we are calling on TensorFlow function. That is session. Now some session dot run the init. Now I have to print. Print session dot run, and here I will put this W variable. That W. Now check what will come. At very initially W equal to 0. So now again if we want to check the, now next time also we want to check the say W parameter what it is learning, and I am writing session dot run say train print session dot run say W. So initially it was 0, now it has increased say 0.099 something. So you can see that it is increasing, the learning parameters it is increasing because our target is to give the result 5. Here the W should be near to 5. So best way is to run it is in the loop. We run it in the loop, or here we are saying is as an epoch. Say for I is iterator, or you can say is here epoch I in say range. Its for loop is basic for loop syntax of Python. Say 1000 times. We are saying 1000 times. Then here one colon. Say session dot run train. So here run. Now we're printing out the print. After 1000 iteration, we are printing the session dot run w. You can print all the things, but I am preferring to print out the after 1000 iteration. So print session run. Yeah, that's enough. So let's see. Yeah, it is giving us 4.9999, so near to 5. So as we expected. And here, I think Professor Rohan Mukherjee taught you the matplotlib. So here we can plot this the weights as well. For this, I am putting the matplot using the matplotlib dot py plot. Sorry, I am running out of time. SPLT. So here we have to take one array to store the W values. So now I am just copying this. For I session document. And I am appending all the new W values. Append session dot run W. Now what I will do, I will plot this plot plt dot plot. So at first I will do some error after that. Yeah, it is giving straight line because all the values are coming 4.99. Already it is trained. So that all I'll do, I will run these things again. Run these things. And run these things. See, near about say 100 iteration, it reached to the 4 point something value. So around 400 to 1000, it is constant. So there is a concept of early stopping. Using that, like after 600 or say 400 iteration, you can stop the trend because it has already giving us the parameters are already trained. So now quickly we'll go through. There are some more concepts like placeholder or like those concepts, so you can change these things. Or here I can change. So here I have put it the like fixed value like 10, 25 like this way. So here instead of that we can take different value. Like here W square minus say 20 plus 100. Obviously it will give us the result 10 because it is W minus 10 square, it's 9.9. So instead of that, these things is 20, 100 or 1 into W square, we can call this as coefficient. Coefficients equal to NP. We are putting this in an array of. So at first it is say 1, then the next value is minus 20, the next value is 100. So here we have to change these things, like here the coefficient is what? X. Here the thing is that the two things, like here 0th row and 0th column. Here it is 1. The minus 20 is in X first row 0th column because this array is in form of one vector, or we can say matrix. here x10, and this 100 is that thing, x second row, 0th column. Okay, simple, like I am just putting over here, so I can change here. W square minus 20 plus 100. And here I am putting this here, that x, I have defined one placeholder. It is called x, we are calling it as a placeholder. So we have to define this placeholder. So placeholder is nothing but here x, we have to define x equal to tf dot placeholder tf dot float. Three value, x00, x10, x20. So there we need 3, 1. 3 row, 1 column. It's enough. So remaining all the things are same. Here this W, in W cannot, it's 10. In the 10 we have to feed those x and coefficient. So how we will feed? Here simply we will directly feed underscore it equal to x coefficients. So again I will copy these things to here as well. That's then. So see, let's check. There is an error. So what we have changed? We have just this coefficient. We have changed these values, the fixed value, to some coefficient and put it in some array. So using this concept, what we have done today, we have done some or truth table. So for the or truth table, we can write that same program here. For the or truth table, what we will do, we will define some x, capital X. Mind it, it is a capital X. So for so that example, we have x1, x2, y. So 0, 1, 0, 1, 0, 0, 1. So the output for OR, the output is 0, 1, 1, 1. Okay. So I am defining one vector as x. I will put here x, I will put say 0, 0, then this 0, 1. Obviously there will be no comma. Then 1, 1, 0, then 1, 1. This will be our x. And what our y will be? Y will be obviously here 0, 1, 1, 1. There are many things. Okay, for this 1 hour time I did not able to go through the inside of the theory. So but our target is to like teach you at least some program. Okay, so I am just going, instead of the inner part of the theory, I am just going to the program so you can implement this or. So here it's equal to Okay, this one x vector and y is our, as I mentioned, that will be 0 and all the things, rest of the things will be 1. Okay, xy we have. Yeah, now the x equal to, again we have to create some placeholder. Okay, placeholder. The shape will be this distance 4 and individual is 2. Okay. So y this will be why for 2, because there are 4 values, individually is 2 for 2. So here obviously y will be here, that 4 1. And we are putting the weights w, it is in actually w1 and w2, vector of w1 and w2. It is also tf dot variable say initially, say we put some initial random value on 1. So I think we have put say 0.2, 0.4 in our theory example, some 0.4. So it is obviously 2, 1, simple. And bias capital B or small b doesn't matter. Bias is variable. Bias we prefer to take initially as 0. 0. So, so in TensorFlow, some tensor. Yeah. So output equal to kf dot, that sigmoid function, kf dot sigmoid that is wx plus v, that is x and w. We have to multiply these two things. Some tensor multiplication command is kf dot matrix means wx plus v. Simple. Now we are calculating some error. We are saying short e equal to what was our, like y hat minus y square. So it is df dot map dot square y is given here. This is Distance. Square then by 2 and overall error is the summation of loss, that is we have to summation of mean over. I forget to do the mean. That's called the option mean. So mean done. Claim equal to the same formula TF dot claim that gradient descent optimizer. Gradient descent optimizer. Learning rate here also 0.1. But is our target minimize P. Now again we have to just initialize the things, say init equal to tf dot global variables initializer. Yeah. Session dot init. Now we'll run a for loop. Okay, that is our last case for I equal to I in range say 10,000. So this much. One like it, one like one. So error. Error means in epoch how much error session got down. This one is the cost because I will cost. It's okay. Don't confuse this case. X means we are putting in the capital X into the X. And we only print when the 10,000 term. Okay. We'll print the epoch. How much is right? Then also we'll print the error, how much error is there. Sorry, Rohan, I am taking 5-6 minutes more. Okay, sorry for this. STR, we have to run this session as the previous example. Session run. And here we have to fit the key that things that cost ticked equal to again these things that X capital X and Here also 4. Here session that output it will bring some just okay. Here we print let's see what. So epoch 0, we are getting some initially some random things. So now 10,000, after 10,000 epoch, 20,000 epoch we are printing, and let's see what after like on like. You can find this video on Facebook, it is live, and my suggestion is just go through this video and work yourself. So in the meantime, if you have any question, just type, okay? So see, after say 1 lakh epoch, the error is 0.000. If we can like increase the number of epoch, we can get more accurate result. But here you can see that first one is 0.0, or say last one is 0.9, 0.9, 0.9. So what was our objective? Our objective is this thing. The first one will be 0, then 1, 1, 1. We are getting similar result. 0.0, then 0.9, 0.9, 0.9. So similarly 0, 1, 1, 1. So in this same example, what we can do, we have performed this with using the OR. So we can in the same way we can perform the AND operation as well. Like it will be 0, 0. It will be 0. So or it will be AND gate. So similar way, I just run the same program for the AND gate. So see what will be the output. In the meantime, I am just showing you one more thing, the concept of D. So here in the AND or any, sorry, in this AND gate, sorry, in this OR gate, if we draw one curve like this one, it is 0, it will be what? 1, 0 here, 1, 1, it will be 0, 1. So here in the position of 0, 0, we have 0. But for the rest of the position, we have 1. So here our task is to classify. If I draw one simple line, we can classify that 0 or 1. This thing 0 or 1. For AND as well, for AND gate as well, it will be 0. It will be 0. It will be 0, and this thing is only the 1. So for the AND gate, our line will be passing from here. One straight line is okay. But for the XOR, that is the major challenging thing. The XOR, the output is 0, 1, 1. Here it is 0. Okay. So for the XOR, here it is 0. Here it is 0. but this position it is 1 and 1. So there are two class members are this and this and this and this. So we need two lines. So for these things we have to increase or deeper the layer where one line is not possible. So previously for AND or and or gate we have only these things, some x1 x2 some say z. For these tasks we have to introduce one hidden layer x2 h1 h2. Here it will be the z because this straight line is for h1, this straight line is for h2. So here if I draw, this is the concept of the deep. We have to depart the architecture, but sorry for this 1 hour webinar it is quite impossible to teach you all the nitty-gritty of inside things. See, it is 5.16 is like to the power into 10 to the power minus 5. So it is near to some 0. Okay, 0 point something. There is also 0 0.0, 0 0.0. It is 0.9. Means it is near to 1. So our for OR gate, sorry, for AND gate, it is also we have successfully trained the weight and bias learning parameters. So any questions? We are already running out of time. You can ask some questions or just type or email me. Already mentioned my email ID again. It is Chandra @JISIASR.org. You can email me.